In this section, you will learn about the chain rule. First up, a quick algebra review of composite functions. In this example, f of x equals 4x squared, g of x is 3 minus x, and we need to find f of g of x. So pause the video, try this one on your own, and restart to check. So here, we will have to take f of 3 minus x, which is going to equal, what we do is take 3 minus x and use that as the input to f of x. So everywhere we see an x, we instead put 3 minus x. So this is 4 times 3 minus x squared, which is equal to 4 times 9 minus 6x plus x squared. And finally, simplifying, we get 36 minus 24x plus 4x squared. In this example, if h of x is equal to the square root of the quantity x to the 5th minus 4, find f of x and g of x so that h of x is equal to the composite function f of g of x. So your job is to figure out who's f of x and who's g of x so that when you do f of g of x, you end up with h of x, which is radical quantity x to the 5th minus 4. So pause the video, try this one on your own, and restart to check your answer. So if we let g of x be the inside function, we could let it be x to the 5th minus 4. Then f of x would have to be the outermost function, which is this radical. So f of x would be radical x. And notice that if we took g of x, which is x to the 5th minus 4, and used it as the input to f of x, then we would end up with h of x. Another option that could have worked was to let g of x be x to the 5th, and then f of x would have needed to be the square root of x minus 4. And once again, we let g of x become the input to f of x, and then that would have turned it in to h of x. So this brings us to the main concept of this lesson, which is the chain rule. If y equals f of u is a differentiable function of variable u, and u equals g of x is a differentiable function of variable x, then y equals f of g of x is a differentiable function of the variable x, and the derivative is expressed in two ways. Version 1 is that dy dx is equal to dy du times du dx. So dy du is just the derivative of y with respect to u. Remember that the y variable is a function that's written in terms of the u variable. So this is just saying we're going to find the derivative of the y function with respect to the u variable. Whereas the u variable is a function written in terms of x. So when we want to find its derivative, we find the derivative of u with respect to x. And version 2 is that the derivative with respect to x of f of g of x is equal to f prime of g of x times g prime of x. And this multiplying of g prime of x, which is the inside function, is what we call the chain rule piece. In this version 1, du dx is the chain rule piece. So now I'm going to help you understand how both of these versions work. In this example, given y equals the square root of the quantity x cubed plus 1, find dy dx using version 1, which is dy dx equals dy du times du dx. So first off, we will need to define our y function and the u function. So y is the outer function, and here we see that the outer function is that we're taking the square root of something. So let's let y be the square root of u. Remember that y is a function of the u variable. Now let's define the u variable. U is a function of x and is the inside function. So inside of the radical, we have x cubed plus 1. Then the derivative of y with respect to u, well, let's write this as u to the 1/2 first. Then dy du, using the power rule, is going to be 1/2 u to the negative 1/2, which is equal to 1 over 2 radical u. And then using the power rule, we can find du dx, which is 3x squared. So now we can apply version 1 to find dy dx. We know it's going to be dy du times du dx. So we take the derivative of y with respect to the u variable times the derivative of u with respect to the x variable. We have dy du, it's right here, 1 over 2 radical u. We have du dx, it's 3x squared. And now all we need to do is substitute for the u variable, which we know is equal to x cubed plus 1. So this is going to equal 3x squared in the numerator over 2 times the square root. Remember, it was u, but we're going to go ahead and substitute back to x cubed plus 1 underneath that radical. And this is the derivative of y with respect to x. So for y equals the square root of x cubed plus 1, the derivative is going to be 3x squared over 2 radical x cubed plus 1. Here we are given y equals the sine of 8 over x. Find dy dx using version 1, which is dy dx equals dy du times du dx. So first, we want to define our variables. Remember that y is a function of u, So we can let y be sine of u if we let u be a function of x, which is the inside function, 8 over x. Now we can find the derivative of y with respect to u. We know the derivative of sine is cosine, so this will be cosine u. And then we can find the derivative of u with respect to x. So let's write u as 8x to the negative 1. Then we can apply the power rule and get negative 8 x to the negative 2, which is negative 8 over x squared. Then dy dx is going to equal dy du times du dx. So this will equal the cosine of u times du dx, which is negative 8 over x squared. Now, to avoid confusion, any function that's not part of the trig function, I suggest you bring it out front. So this would be negative 8 over x squared times the cosine of u. Because one of the common errors that students make is that they think they're taking the cosine of u times this other function. So to avoid that confusion, take that function, write it out front. Now, ultimately, our function was written in terms of x, so we want to substitute for the u variable back to the x variable. So this is going to be equal to negative 8 over x squared times the cosine of 8 over x. So the derivative of y equals sine of 8 over x is negative 8 over x squared times the cosine of 8 over x. Now you will learn how to use version 2 of the chain rule, which is that the derivative with respect to x of a composite function, f of g of x, is equal to f prime of g of x times g prime of x. And we refer to this multiplying by g prime of x as applying the chain rule piece. Now, in this notation, f is the outer function and g is the inside function. Then the chain rule says to take the derivative of the outer function, f prime of g of x, times the derivative of the inside function, g prime of x. In this example, y is equal to the quantity 7x to the 5th plus x raised up to the 4th power. Find y prime. Now, to use version 2 of the chain rule function, what we want to do is take the derivative of the outer function. Remember, that's f prime of g of x, and then take that times the derivative of the inside function. So that will be g prime of x. Now, the derivative of the outer function is evaluated at your inside function. So a way you can think about that is we have some stuff raised up to the 4th power. Then the derivative of that using the power rule would be 4 times the stuff, which is 7x to the 5th plus x, raised up to the 3rd power. So this is f prime of g of x. Then the chain rule piece says you then have to take it times the derivative of what's inside. So then what's inside is 7x to the 5th plus x. We have to take that derivative, and that's going to be, using the power rule, we will get 35x to the 4th plus the derivative of x, which is 1. And this is g prime of x. So we take the derivative of the outer function, which we had some stuff, to the 4th power. So you take 4 times the stuff to the 3rd power. Then the chain rule says that you have to take it times the derivative of your stuff. So then y prime equaling 4 quantity 7x to the 5th plus x to the 3rd times the quantity 35x to the 4th plus 1 is the derivative of y equals the quantity 7x to the 5th plus x to the 4th. Now, if we compare this to version 1, this first part here is dy du, and then, of course, already the u being substituted back to x, times the second part, which is du dx. So both versions of the chain rule are telling you to do the same thing. It just looks a little different in the processes. Typically, you will find that we use version 2 most often. In this example, y equals the secant of the quantity 7x cubed. Find y prime. So what we have to do is first find the derivative of the outer function. Now, the outer function in this case is the secant. So the derivative of secant of some stuff is going to be secant stuff tangent stuff. So that means it will be secant of the quantity 7x cubed times tangent of the quantity 7x cubed. Then the chain rule tells us that we have to take it times the derivative of the inside function, which is 7x cubed, and that derivative is 21x squared. So then y prime is equal to 21x squared secant of 7x cubed tangent 7x cubed. Here we have f of x equals -3 over the quantity 13x plus 2 cubed, and we have to find f prime of x. In order to use the power rule, we need to rewrite f as -3 times the quantity 13x plus 2 to the -3rd power. So the outer function is that we have -3 times some stuff to the -3rd power. So now we can use the power rule. We know this exponent will come down and multiply the coefficient, so that's going to be 9 times the stuff, which is 13x plus 2. We have to subtract 1 from the exponent, so it becomes -4. And then the chain rule tells us that we have to take it times the derivative of what's inside, which would be 13. So then f prime of x, we need 9 times 13, which is 117. And then this expression needs to go to the denominator. So we have 13x plus 2 raised up to the 4th power in the denominator. In this example, we have f of x equals the square root of 5x to the 4th plus 7x, and we have to find f prime of x. So pause the video, try this one, and then restart when you're ready to check your answer. First, we need to rewrite f of x as the quantity 5x to the 4th plus 7x raised up to the 1/2 power. Now we can apply the power rule, and because we have a composite function, we know that we will have to use the chain rule. So the outer function here is that we have some stuff raised up to the 1/2 power. So then when we find f prime of g of x, that means we have to find the derivative of stuff to the 1/2. So that's going to be 1/2 times our stuff, 5x to the 4th plus 7x. And then we subtract 1 from the exponent. It becomes -1/2. And then the chain rule tells us that we have to take it times the derivative of our stuff, g prime of x. So that's going to be 20x cubed plus 7. So then now we know that f prime of x is equal to, in the numerator, we are going to have 20x cubed plus 7. And in the denominator, we will have this 2. And to make this -1/2 into a +1/2 exponent, we have to move this to the denominator, and we can write it as radical 5x to the 4th plus 7x. Or if you wrote it as 5x to the 4th plus 7x raised up to the 1/2 power in the denominator, that's fine too. Next, you will learn how to use the product rule or quotient rule combined with the chain rule. In this example, find h prime of x if h of x is equal to x to the 5th tangent of x squared. We can see right away that we have the product of two functions. So we know we are going to need the product rule. We can say that f is going to be x to the 5th, and tangent of x squared is g. Now, tangent of x squared is a composite function. So g is a composite function. And anytime you have a composite function, that tells you you are going to have to use the chain rule. So if we work on h prime of x, we know that we will have to do f prime g plus f g prime. So then f prime means we have to take the derivative of x to the fifth, so that will be 5x to the fourth times g, which is tangent of x squared. We bring down the plus sign. Then f is x to the fifth, and we have to take that times g prime. Now remember, we said g is a composite function, so that tells us we are going to have to use the chain rule there. So the outer function here is that we have the tangent of some stuff. So when we do f prime of g of x, we have to do the derivative of tangent of some stuff, which we know is secant squared of the stuff. And our stuff is x squared. Then the chain rule tells us that we have to take it times the derivative of the stuff. So in other words, we have to find g prime of x, and that's going to be 2x. So now let's clean up this derivative a little bit. We've got 5x to the fourth tangent of x squared plus, we've got this 2x out here that's going to multiply the x to the fifth. So we have 2x to the sixth secant squared of x squared. And now between these two terms, we could factor out an x to the fourth, and we would have left 5 tangent of x squared plus 2x squared secant squared of x squared. And this is our derivative. In this example, find y prime if y is equal to the quantity 3x squared plus 5 over 4x raised to the second power. Because we have a composite function, stuff squared, we know we will have to use the chain rule. Now, because the stuff is a quotient, we will also have to use the quotient rule, which we know is f prime g minus f g prime over g squared. So we will need to combine both of these rules. Now, to find y prime, we have stuff squared, and we have to find the derivative of that, which of course would be 2 times our stuff, which is 3x squared plus 5 over 4x. And now we subtract 1 from the exponent, and our exponent is 1, meaning we can leave it off. Now we have to apply the chain rule here. So now, in order to find the derivative of our stuff, we have to apply the quotient rule. So we have to do f prime, which would be the derivative of the numerator, which is 6x, times g, which is our denominator, 4x, minus f, which is the numerator, 3x squared plus 5, times g prime, and the derivative of 4x is 4. That whole thing is over g squared, so the quantity 4x squared. So in terms of the chain rule, now we have f prime of g of x times g prime of x, and we just need to simplify. So then y prime is going to equal, this 2 here will cancel with the 4 here, and we can write this as 3x squared plus 5 over 2x. So far, all we've done is cancel this 2 with this 4. Now let's work on this expression. 6x times 4x gives us 24x squared. Then we have this negative sign that has to be distributed to both of these terms, along with this 4. So you can think of it as a negative 4 times 3x squared would be negative 12x squared. And then a negative 4 times a 5 means we have to subtract 20. And that's over the quantity 4x squared, which is 16x squared. Continuing to simplify, let's make one big fraction bar. We've got in the numerator 3x squared plus 5. And here we have 24x squared minus 12x squared. So that leaves 12x squared. And then we bring down the minus 20. Now in the denominator, we have 2x times 16x squared. So that's 32x cubed. We can continue to simplify, get this fraction bar. We've got the 3x squared plus 5. Then from this expression, we can factor out a 4, and we would have left 3x squared minus 5. And in the denominator, we still have 32x cubed. And then finally, this 4 will cancel with the 32, and we can simplify. The numerator will be 3x squared plus 5 times 3x squared minus 5. We already said the 4 will cancel with that 32, so it becomes an 8, and we still have x cubed in the denominator. Now you will learn how to find derivatives when you have to use the chain rule more than once. In this example, find each derivative. First up, we have y equals cosine cubed of 4x. So this is the same as saying cosine of 4x, that whole quantity, cubed. So this is a multi-layer composite function. The outermost function is that we have some stuff cubed. So f of x equals x cubed. Then inside of that, we also have a composite function of cosine of some stuff. So let's call that g of x is cosine x. And then finally, we have 4x. So let's call that h of x equals 4x. Then what we have is that our function y is equal to f of g of h of x. And each of these layers has to have a chain rule. So as we go from f of x to g of x, we're going to be applying a chain rule. And when we go g of x to h of x, we're going to have to apply a second chain rule. So let's see how this will work. Y prime is going to equal, remember we said the outermost layer was that we have some stuff cubed. So then we have to take 3 times the stuff, which is cosine of 4x squared, because the derivative of stuff cubed is 3 stuff squared. Now we have to apply the chain rule, and we know that the derivative of cosine of some stuff is going to be negative sine of the stuff, which is 4x. And then the chain rule says that we have to take the derivative of that stuff, which is 4. So we had to apply the chain rule twice here because we had 3 levels in our composite function, f of g of x, which was the cube function to the cosine function to the multiply times 4 function. And when you go from one level to the next, you have to apply a chain rule. So when you have 3 layers in your composite function, you will be applying the chain rule twice. Now simplifying this, we get that y prime is going to equal, we've got this 3, there's a negative sign here, times this 4, so that's negative 12 out front. Then we've got this cosine of the quantity 4x, that whole thing being squared. We can write that as cosine squared 4x. And then we have times sine 4x. And this is our derivative. Here we have to find the derivative of y equals tangent of radical sine 2x. Now don't make the mistake of thinking that you will use the product rule. This is not tangent times radical sine 2x. This is tangent of radical sine 2x. Well, we can rewrite this as tangent of sine 2x to the 1/2 power. Now this is a multi-layer composite function. The outermost function that we have is not the radical, it's the tangent function. So f of x would equal tangent of x. Then the next highest level in the composite function would be this radical. So g of x is equal to radical x. Then inside the radical, we have sine of some stuff. So then h of x is going to equal sine x. And then finally, living inside of that, we could call it k of x is equal to 2x. So then y equals tangent of radical sine 2x is actually y equals f of g of h of k of x. So we have 4 layers in our composite function, and we know that each of those layers is going to require a chain rule being applied. So that means in this case, because we have 4 layers in our composite function, we will have 3 chain rules that have to be applied. So let's get to work on this derivative now. We will have y prime then is going to equal, remember the outer function we said is tangent, so we have tangent of some stuff, and the derivative of tangent of some stuff will be secant squared of that stuff. I'm going to go ahead and write it as radical sine 2x. Now, the chain rule tells us that we have to find the derivative of that stuff, which is square root of some other stuff. So then the derivative of square root of some stuff is 1/2 times the stuff, which is sine 2x, then subtract 1 from the exponent, and we get negative 1/2. Then we have to apply a chain rule there. And the derivative of sine of some stuff is cosine of the stuff. And then applying the chain rule to that stuff, we know the derivative of 2x is 2. And this 2 is not inside the cosine function. We're only taking the cosine of 2x here. So now if we clean this up, y prime is going to equal, we know that we're going to have to send this sine 2x to the negative 1/2 into the denominator. So let's go ahead and get a fraction bar going. This secant squared radical sine 2x stays in the numerator. This 1/2 right here is going to cancel with this 2. This radical sine 2x needs to go into the denominator. And this cosine of 2x stays in the numerator. And this is our derivative. So because we had 4 levels in the composite function, we had f of g of h of k. 4 levels in the composite function means 3 chain rules will have to be applied. Next up, you will learn about factoring derivatives that have fractional and negative exponents. So in this first example, we do an algebra review where we have to factor each expression. In this first example, we have 6x to the negative 2y plus 4/5 x squared y to the negative 3. Anytime you have fractional coefficients, I strongly recommend that you get the common denominator of the coefficients first. So clearly, that's going to be 5. This first expression, we need to multiply by 5 over 5. So we have 30 x to the negative 2 y plus, we already have the denominator of 5 here, so 4x squared y to the negative 3. Now we can easily factor the numerator. The greatest common factor for these two terms is going to be 2x to the negative 2 y to the negative 3. Remember, you always have to pull out the smaller exponents. Now all you have to do is see this term divided by this term gives you this term. So 30 over 2 is 15. X to the negative 2 over x to the negative 2 is 1. And y to the 1 over y to the negative 3 is y to the 4th. Plus, if we do this term divided by this term, 4 over 2 is 2. X squared over x to the negative 2 will be x to the 4th. And y to the negative 3 over y to the negative 3 is 1. And we still have that 5 in the denominator. Now to simplify, all we need to do is get these negative exponents moved to the denominator so that they become positive. So in the numerator, we will have this 2, and we will have the 15y to the 4th plus 2x to the 4th. And in the denominator, we already had the 5. And then the x to the negative 2, y to the negative 3 will move to the denominator to become x squared y to the 3rd. And now the expression is factored and is in simplest form. In this next example, we have 8x to the 3/2 minus 18 over radical x. So pause the video, try this one, then restart when you're ready to check your answer. Now we can rewrite this expression as 8x to the 3/2 minus 18x to the negative 1/2. Now we can go ahead and factor. Our GCF is going to be 2x to the negative 1/2. And now you do the division to see what's left. 8x to the 3/2 over 2x to the negative 1/2 is going to be 4x squared. Because when you do 3/2 minus a negative 1/2, it becomes 4/2, which is 2. Minus, here, when we divide 18x to the negative 1/2 by 2x to the negative 1/2, we get 9. Simplifying, of course, this 2 stays in the numerator. This x to the negative 1/2 goes to the denominator, and you can either write it as x to the positive 1/2, or you can write it as radical x. Now this 4x squared minus 9 is the difference of two squares, so we can factor that into 2x minus 3 times 2x plus 3. And our result is now in simplest factored form. Remember, we will leave radicals in the denominator. We will not rationalize the functions. In this example, we have h of x is x squared radical 1 minus x squared, and we have to find h prime of x. Let's first rewrite h of x as x squared times the quantity 1 minus x squared raised up to the 1/2 power. Now, we recognize that we are going to have to use the product rule here, so we know that's coming, and we can let x squared be f and 1 minus x squared to the 1/2 be g. So we will need to do f prime g plus f g prime. So then f prime is going to be 2x times g, which is the quantity 1 minus x squared to the 1/2. Bring down this plus sign. F is x squared, and then we have to take that times g prime. Now notice that g is a composite function. And that tells us we will need to use the chain rule. So we have some stuff raised up to the 1/2 power. So that means the derivative is going to be 1/2 times the stuff, which is 1 minus x squared, raised up to the power of 1/2 minus 1, which is negative 1/2. And then the chain rule tells us that we have to take it times the derivative of what's inside, and the derivative of 1 minus x squared is negative 2x. Now this is going to equal 2x times the quantity 1 minus x squared to the 1/2. And now over here, we have a plus sign here, but we have a minus sign here. So we will be subtracting. We've got an x squared times an x. That's going to be an x cubed. And we see that the 2 in the denominator here will cancel with the 2 up here. And then we have left this quantity 1 minus x squared to the negative 1/2 power. So now we can factor. We can pull out a factor of x. We can also pull out a factor of 1 minus x squared to the smaller exponent, which is negative 1/2. And then you just do the division to see what's going to be left. If we divide this term by this greatest common factor, we see that we're going to have a 2. The x's will divide out, and this 1 minus x squared to the positive 1/2 over 1 minus x squared to the negative 1/2 is going to be 1 minus x squared to the half minus negative a half, which is adding, so that becomes 2 halves, which is 1, so we can leave the exponent off. Then we have this subtraction sign, and then x cubed over x is going to be x squared, and then the 1 minus x squared to the negative half over itself would just be 1. Continuing to simplify, we've got this x in the numerator. We've got this 1 minus x squared to the negative half, so it will need to go to the denominator, and I will write it as radical 1 minus x squared, or of course you can write it as 1 minus x squared raised up to the positive 1/2 there. Now inside the brackets, we need to distribute, so we will have 2 minus 2x squared, and then we still have this minus x squared, and then finally we have x times the quantity 2 minus 3x squared, that's in the numerator, and then this radical 1 minus x squared in the denominator. And this is our result in simplest form. In this example, we are given y equals x over the cube root of the quantity x squared plus 4, and we have to find y prime. Now, we could choose to use the quotient rule if we like, or we can rewrite y equal to x times the quantity x squared plus 4 to the negative 1/3 power, and then now we can apply the product rule. We can let x be the f, and x squared plus 4 raised up to the negative 1/3 can be g. And we will need to do f prime g plus f g prime. So f prime is the derivative of x, which of course is 1, and we have to take that times g, which is x squared plus 4 to the negative 1/3 power. Bring down the plus sign. F is equal to x, and then we have to take that times g prime. Now we need to recognize that g is a composite function, and that means we will have to use the chain rule when we find its derivative. So now we're ready to find g prime. We have stuff to the negative 1/3 power. So then g prime is going to be negative 1/3 times the stuff, which is x squared plus 4, raised up to the power of negative 1/3 minus 1. So if we do negative 1/3 minus 1, that's the same as negative 1/3 minus 3/3, which is negative 4/3. So negative 1/3 minus 1 means our exponent now is negative 4/3. Now the chain rule tells us that we have to take it times the derivative of what's inside, and the derivative of x squared plus 4 is 2x. Let's simplify. This first term is just x squared plus 4 to the negative 1/3 power. And now we have a plus sign here with a minus sign here, so we will be subtracting. Now the coefficient is going to be 1/3 times 2, so we'll be subtracting 2/3, and then we have an x times an x, which is x squared. And then we have this x squared plus 4 to the negative 4/3 power. Let's simplify. Whenever we have a fractional coefficient, I recommend that you get the common denominator of the coefficients first. We know our common denominator is going to be 3. So that means this term has to get multiplied by 3/3. So we have 3 times the quantity x squared plus 4 to the negative 1/3 minus, now for this term, we already have the 3 in the denominator, so we will have 2x squared times the quantity x squared plus 4 to the negative 4/3 power. Now we are ready to factor. We have 3 in the denominator still. There's no numerical coefficient that we can take out. Here we have an exponent of negative 1/3. This has an exponent of negative 4/3. So this one is smaller, so that's what we have to factor out. X squared plus 4 to the negative 4/3 power. Now from this first term, we see we get a coefficient of 3. Then when we take x squared plus 4 to the negative 1/3 over x squared plus 4 to the negative 4/3, we have to do negative 1/3 minus a negative, so it becomes plus 4/3. Well, that's 3/3, which is an exponent of 1, so this will be times x squared plus 4 to the 1, which means we can leave it off. Now we have to subtract, and from this term, the x squared plus 4 to the negative 4/3 is what we factored out, so we just have left the 2x squared. Now let's simplify. Now this x squared plus 4 to the negative 4/3 will have to join the 3 in the denominator. So that's going to be 3 times the quantity x squared plus 4 to the positive 4/3. Now inside the brackets here, we have to distribute this 3. We would have 3x squared and then minus 2x squared. So we have x squared and then 3 times 4. So we need to add 12. And this is our answer in simplest form. And just so you can see how using the quotient rule would give you the same result, I've worked it out for you here if you'd like to take a look. Next up, we find the equation of a tangent line. In this example, find all points on the graph of f of x equals the cube root of the quantity x squared minus 1 squared, where the tangent line is horizontal or vertical. Now, a horizontal line, of course, means the slope is going to be 0, whereas a vertical line means the slope is going to be undefined. Now, to get the slope of the tangent line, we know that comes from f prime of x. Now, to find the derivative of this, let's first write f of x as the quantity x squared minus 1, and using an exponent, it will be to the 2/3 power. So then to find the derivative of that, we have a composite function, so we know that we're going to use the chain rule. So f is that we have stuff to the 2/3 power. So f prime is going to be 2/3 times that stuff, which is x squared minus 1. Then we have to subtract 1 from the exponent. 2/3 minus 3/3 is negative 1/3. And then we know that the chain rule tells us that we are going to have to take that times 2x. Now, if we clean up this derivative, in the numerator, we will have this 2 times 2x, so we're going to have 4x. In the denominator, we will have a 3, and we are going to have x squared minus 1 to the positive 1/3, or we can write it as the cube root of x squared minus 1. Now, we are interested in the places where this slope is either 0 or undefined. And a rational expression is going to equal 0 whenever its numerator is 0, as long as the denominator is not. And we can see that at x equals 0, the numerator will be 0, and the denominator will not be 0. A rational expression is undefined whenever its denominator is equal to 0, and this is going to happen when x is either plus 1 or minus 1. Either one of those will result in a 0 in the denominator, making the slope be undefined. Now, we had to find all the points where this happens, so that means we're going to need x and y coordinates. So let's take a look at f of 0 means we have to do the cube root of 0 squared minus 1 squared. And of course, that's just going to equal 1. We need to evaluate f of 1. And notice we're not plugging into f prime here. To get the y value, we have to plug into f. So that means we're doing the cube root of 1 squared minus 1 squared, and this is going to equal 0. We also have to plug in f of negative 1. That's going to be the cube root of negative 1 squared minus 1 squared. That's just 1 minus 1, which is also 0. So now this means we have the point 0, 1. This gives us the point 1, 0. And this gives us the point negative 1, 0. When x equals 0, we know the slope of the tangent is 0, so that tells us we have a horizontal tangent at the point 0, 1. So we have a horizontal tangent line at 0, 1. And when x was 1 and negative 1, the slope was undefined. So that tells us that those 2 points at 1, 0 and negative 1, 0 will be where we have a vertical tangent line. So there's a vertical tangent line at 1, 0 and negative 1, 0. In this example, find the equation of the line tangent to f of x equals 3 cosine x plus cosine of 1/2 x at the point pi negative 3. Now, to find the equation of a line, we know we need 2 things, a point and a slope. And the slope of the tangent line is going to come from the derivative, f prime of x. Now, we know the derivative of cosine x is negative sine x, so for this first term, we get negative 3 sine x. And for the second term, notice this is a composite function. It's not cosine x, it's cosine of stuff. So the derivative of cosine of some stuff is going to be negative sine of the stuff. And then the chain rule tells us we have to take it times the derivative of the stuff. So the derivative of 1/2 x is 1/2. So now this is going to equal negative 3 sine x minus 1/2 sine of 1/2 x. Now this gives us a formula that tells us the slope of the tangent at every point on f of x. We are only interested in the slope at the point pi negative 3. So let's evaluate the slope of the tangent at the point pi negative 3. That means we have to do f prime of pi. So that's going to be negative 3 times the sine of pi minus 1/2 times the sine of 1/2 pi, which is pi over 2. So this is going to equal negative 3. Now looking at the unit circle, we know the sine of pi is 0 minus 1/2 times the sine of pi over 2, which is 1. So this slope is going to simplify to be negative 1/2. Now that we have a point and a slope, we can plug into point-slope form. Which is y minus y1 is equal to m times x minus x1. Now, if we do that, we're going to have y minus, the y value is negative 3, is equal to, we have to do the slope, which is negative 1/2 times x minus the x value, which is pi. So we have y plus 3 is equal to negative 1/2 x plus pi over 2. Now to get the y by itself, we're going to subtract 3 from both sides. And on the right-hand side, I'm going to subtract 6 over 2. So we have y is equal to negative 1/2 x plus pi minus 6 over 2. And this is the equation of the tangent line. Now you will learn how to find higher order derivatives involving the chain rule. In this example, h of x is equal to sine of x cubed. Find h double prime of x. Just to make sure you're crystal clear on h of x, it's equal to sine of the quantity x cubed. The only thing being cubed is the x. Now, in order to find h double prime, we have to find h prime first. So h prime of x, we see that h of x is a composite function, which tells us we will be using the chain rule. So to find h prime of x, we know h of x is sine of some stuff, and the derivative of sine of some stuff is cosine of the stuff, so cosine of x cubed, and then the chain rule tells us that we have to find the derivative of what's inside, which is 3x squared. So now we know that h prime of x is 3x squared cosine of x cubed. Now, to find h double prime of x, we have to find the derivative of h prime of x, and we notice right away that this is a product. We have this function times this function. So we are going to have to use the product rule, and we will let 3x squared be f and cosine of x cubed be g. Then to find h double prime of x, we will need to do f prime g plus f g prime. So this is going to equal f prime, which is 6x, times g cosine of x cubed. Bring down the plus sign. F is 3x squared times g prime, which is going to be the derivative of cosine of x cubed, which of course is a composite function. So the derivative of cosine of some stuff is negative sine of the stuff. And then chain rule tells us to take it times the derivative of the stuff, which would be 3x squared. So this expression inside the brackets is all g prime, which is the derivative of cosine x cubed. So let's clean this up. We have 6x cosine of x cubed. And then from this second term, This minus sign here and the plus sign here means we'll have to subtract. We have 3x squared times 3x squared, 9x to the fourth, times the sine of x cubed. Now from these two terms, we can factor out a 3x, and we have left 2 cosine of x cubed minus 3x cubed sine of x cubed. And there's our derivative in factored form. In this example, k of x is equal to cotangent 3x. Find k double prime of x. Pause the video, try this one on your own, then restart to check your answers. So first, we have to find k prime of x. We have a composite function here. So that tells us we are going to have to use the chain rule. We know that the derivative of cotangent of some stuff is negative cosecant squared of the stuff. And then chain rule says we have to take it times the derivative of the stuff. And the derivative of 3x is 3. So k prime of x is negative 3 cosecant squared of 3x. Now remember that having the squared here is just shorthand for negative 3 times cosecant of 3x, that whole entire quantity being squared. So now this is also a composite function, but it actually has 3 layers. So the outermost function, if we call that f, is that we have something being squared. And then inside of that, we have a cosecant function, cosecant of some stuff. So then g of x would be cosecant x. And then finally, living inside the cosecant, we can say h of x is equal to 3x. Then k prime of x is equal to f of g of h of x. So from every level of the composite function to the next one is a chain rule. So that means when you find the derivative of k prime, you're going to be using the chain rule twice. Now, to find k double prime of x, we want to think of k prime as negative 3 times some stuff squared. So then that derivative is going to be negative 6 times the stuff, which is cosecant 3x, to the first power, because we had to take 2 and decrease it by 1. Now, the chain rule tells us that we have to find the derivative of cosecant of some stuff. So that's going to be negative cosecant of the stuff, which is 3x, times cotangent of the stuff, 3x. And then the chain rule tells us we have to find the derivative of what's inside that, which is 3x, and that derivative is 3. So then k double prime of x, we've got a -6 times a negative here. That's going to make it positive times 3. So we have positive 18. We have a cosecant 3x times a cosecant 3x. So cosecant squared of 3x times cotangent of 3x. And this is the answer in simplest form. So if you got this one right on your first try, I want you to congratulate yourself because this was a tough one. And if you made a mistake somewhere, don't feel bad. Just learn from the mistake and it'll help you catch it the next time.